Let's talk about auto-scaling groups. As I mentioned before, auto-scaling groups provide support for horizontal scaling, in other words, scale out for your landscape. They can be triggered by a variety of events or actions or conditions in your environment, and they can either launch new instances or terminate existing instances that were created from that auto-scaling group. Now, availability, cost, and system metrics can all figure into scaling. And there's four scaling options that we have. First is maintain. We can keep a specific number of instances running at all times. The next is manual. We can go out and say we want to scale up to 3 instances, for example, and just type in 3, and AWS will scale to 3 instances for us. We can also schedule instances based on a time schedule. If we know that during a certain period of time we're going to need extra capacity, then we can set up a schedule that will spin up instances before that and then shut them down after that time period. Then we also have dynamic scaling, and we can scale based on real-time metrics of the systems that we have. Now, the first step in creating a auto-scaling group is you have to create a launch configuration, and that's just defines what AMI you're going to use, what type of instance you're going to use, and then once you have that launch configuration, you can assign that to an auto-scaling group. Now, part of this is defining what size you want the auto-scaling group to be, what VPC, and what subnets you want to deploy new instances in. You can also attach the auto-scaling group to an elastic load balancer. And something to note here is you define a health check grace period. One of the features of an auto-scaling group is it continually monitors the health of the instances in that auto-scaling group. And if something becomes unhealthy or unavailable, then it's going to compensate by spinning up a new instance. And this health check grace period defines how long you want to give the instance to come up and get settled before it's subject to that health check. Now, later on, we're going to learn about something called a cooldown period. And you should note that health check grace period is different from a cooldown period, and we'll talk about that later. One option for an auto-scaling group is to keep at a certain number of instances. Another option is you can scale based on certain attributes and metrics of the systems inside that scaling group. In this case, for example, we can scale based on average CPU utilization or maybe network traffic. Now, there are a few scaling types that we can take advantage of. First is maintain. It's just a way to maintain a certain number of instances. And we would use this when we say need 3 instances always. The other method is we can do it manually. We can go out to the console or the command line interface and just tell AWS we need this many units, and it will react accordingly. We have the scheduled scaling type, which we can define maximum, minimum number of instances based on specific times. So, for example, maybe every Monday morning our website gets crushed with traffic, so we might want to set up some extra app servers and web servers during that time. Then we have dynamic scaling, which is in response to certain metrics inside our environment. In this case, maybe when our CPU utilization gets to 70% across all our instances, let's add more servers. Now we have a few different scaling policies in that dynamic umbrella. We can use a target tracking policy. And this just means that we set a certain target goal, and if we go above that goal, for example, we scale up. And here we're saying when the CPU utilization gets to 70% on the current instances, let's scale up. We also have 2 other scaling policies. One is a simple scaling policy, the other is a step scaling policy. And I'll explain step first. So a step scaling policy can respond to scaling needs with more granularity and more logic. So normally a simple scaling policy is going to scale up, and then it's going to wait until the health check grace period and the cooldown period expires before evaluating whether to add another machine. Step scaling, on the other hand, allows us to scale based on different items, not necessarily just being restricted to the health check duration and the cooldown duration. Now, in this example, I'm kind of exaggerating when to use simple versus step. But in essence, simple ignores alarms during launch and cooldown, while step allows you to configure more logic in the scaling, and it isn't governed by a cooldown period. So speaking of cooldown, let's talk about that in a little bit more detail. It's a configurable duration that gives your scaling a chance to come up to speed and absorb some load. The default cooldown period is 5 minutes, 300 seconds. It automatically applies to dynamic scaling, and you can optionally use it in manual scaling, but it's not supported in scheduled scaling. And you can also override the default cooldown via scaling specific cooldown. Where you might want to do that is maybe in a scale down policy. Because in a scale down policy, you're just terminating instances, there's really no need to wait as long as you would if you were bringing up instances. So the end result is you could scale down faster than having to wait the same period as when your systems spin up. Now, if you remember, we talked about a health check grace period, and that's the amount of time that we're going to allow before we want that instance to be checked for its health. So the idea is the system has to boot up, it has to load whatever it's going to load, and get settled before we start checking it for its health. A cooldown period, on the other hand, is after a scaling event happens. It's the period of time that we decide to wait until we can trigger another scaling event. So let's look at an example. If we had no cooldown period, we could get into this loop where we're triggering instance after instance after instance very rapidly, and maybe we'll overshoot our need. With a cooldown period, we allow the environment to stabilize once we spin up that new instance to take on the load to see if we truly need yet another instance. You can also scale based on some other external conditions. In this case, we're showing a landscape where we're scaling based on the number of items in an SQS queue. And we're using a lambda function to check the queue size. And we're also checking the capacity of the auto-scaling group. If we decide we need more instances to get through that queue faster, we can trigger a custom metric, which then in turn triggers an auto-scaling event to add more instances.